All right, tomorrow, your quiz is over sections 2.4 and 2.6. So 2.4 is our average rate of change. 2.6 was our odd, even, neither, algebraically, graphically, and talking about transformations of functions, okay? There's a bunch of different ways you can find average rate of change. I shouldn't say that. Not a bunch of different ways, but like, we're not just talking about linear, where it's constant, it's the same from one step to the other. You're going to be given different situations, I should say. Like these first two, 51 and 52, what did they give you? They gave you, what are you looking at for 51 and 52? So it should be on assignments. Do you guys see that they gave you an XY chart?
Yes.
Right? So they're giving you the two pairs. For 53, 54, they're giving you a graph, right? For 55 and 56, they gave you an equation, so you got to plug in x's. For these ones over here, they're word problems, but they still gave you the x and y that you need. So we're going to go through some examples here. If I want to find in 51, if I want to find the average rate of change between where x is 4, so right here, you guys with me? 4, 12 is my first ordered pair, and where x is 8, so it's 8, 8. So you have the ordered pair 4, 12, and the ordered pair 8, 8. Does everybody agree with me? Okay, average rate of change. What's that same formula that we're going to use that we're familiar with? Y2 minus Y1. Right, here's my X and here's my Y. So I'm going to say, me personally, Mrs. Meadows, I'm going to say 12 minus 8. If I say 12 minus 8 in the numerator, what needs to be in the denominator? 4 minus 8. Garnell, you are 100% right. Why did you put 4 first? Because I put the 12 first. Perfect. So 12 minus 8 is what? 4 over, what's 4 minus 8? Negative 4. So what is your average rate of change for this function? Negative 1. What is that telling you about your average rate of change? What does this tell you about your function between those 2 points? It's going which direction? Going down, okay? It's decreasing. So between where x is 10 and where x is 30. So x is 10 right here and x is 30 right here. So your two ordered pairs are 10, negative 5 and 30, 30. Agreed? Yeah. Set up your problem so you can see it right in front of your face. All right? All of this is comparing data between two ordered pairs. They're not going to tell you the ordered pair is blank, blank. You got to figure it out, whether from the chart, from a graph, from a word problem. So here, I'm going to say negative 5 minus 30. So if I put negative 5 first on top, what goes on the bottom? Okay, so 10 minus 30. What's negative 5 minus 30? Negative 35 over 10 minus 30 is negative 20. A negative divided by a negative gives you a positive, and I can divide both top and bottom by 5, right? So this becomes 7 over 4. So your average rate of change between these two intervals on the x-axis with the given information is 7 over 4. Questions? All right, same thing applies, guys, if you have a graph. They're telling you where to look. If they're telling me where x is negative 1, well, here is negative 1. On my, look, first of all, do you see how this is 0 here and then this is positive 1? So then if this is 0, then this is negative 1. Do you see how it like skips a little bit? Okay. So this point right here is negative 1, comma what? 2. And then I look over here, it's between where x is 2. So this is 1, this is 2. So x is 2. And what is my y value? Well, if this is 2, so this would be 1, 2, 3, 4, 5, 6. So it'd be 2, 6. Now what do I do? Now that I figured out what the points are, what do I do? Y2 minus Y1. If I were you, I would rewrite it real quick. I would just say negative 1, comma 2, and then I would write 2, comma 6, just so we don't make any silly mistakes. So I'm going to say, fine, y is first, 6 minus 2. If I put 6 minus 2 on top, what am I putting on the bottom? 2 minus negative 1, perfect. So 6 minus 2 is 4, and 2 minus negative 1 is So your average rate of change here is what? 4 over 3. Good. All right, we okay? Same thing would happen, guys, for 54. You guys can do 54. I just want to make sure we hit every little piece. How long are we in here till? 12? Okay. All right, how is 55 and 56 a little bit different? It gives me an equation, and it tells me two x values to plug in. This one's going to take a little longer, guys. There's a little more work involved here. I have x squared minus 2x. They want me to find the average rate of change between where x equals 1 and x equals 4. Everybody with me? So what do I do first? I have to find these two ordered pairs. How would I find them? I'm going to plug in. So I'm going to evaluate. I'm going to say 1 squared minus 2 times 1. What's 1 squared? Minus 2 is? So 1 minus, so I get negative 1. So when I plug in x equals 1, I get out y equals negative 1. So this point here is 1 comma negative 1. Now I'm going to do the same thing, but I'm going to evaluate where x is what? 4. So I have 4 squared minus 2 times 4. What is 4 squared? And then 16 minus 8 gives me 8. So this ordered pair is plug in 4, get out 8. Have I found the average rate of change over the two intervals given? No, not yet. What do I have to do? y2 minus y1. So it doesn't matter if you do negative 1 minus 8 or 8 minus the negative 1. I'm just going to say negative 1 minus 8. So if I put negative 1 first for y, what do I have to put first for x? So then 1 minus 4. What is negative 1 minus 8? Negative 9. What is 1 minus 4? And a negative divided by a negative gives me a positive. Perfect. So your average rate of change between the two intervals x equals 1 and x equals 4 is positive 3. Questions? All right, same situation. They gave me a function. This time they said g of x equals x plus 1 quantity squared. And then they gave me the intervals to look at between where x equals negative 1 and x equals positive 5, correct? Yes. So let's plug in. I have negative 1 plus 1 squared. What's negative 1 plus 1? 0. So when I plug in negative 1 for x, I get out 0 for y. Agreed? Yes. Okay, so next I'm going to evaluate, excuse me, where x is 5. So I have 5 plus 1 squared. What is 5 plus 1? 6. I gotcha. And then 6 squared is? 36. Good. So when I plug in 5, I get out 36. Have I found the average rate of change? No. What do I need to do? Y on the top and XX on the bottom. So I'm going to say 36 minus 0. If I do 36 first on the numerator, what do I have to do first in the denominator? So it's 5 minus negative 1. Make sure you keep your signs correct. So I have 36 over, what's 5 minus negative 1? 6. What's 36 divided by 6? 6. So your average rate of change between the intervals of x equals negative 1 and x equals 5 is positive 6. Questions? All right, let's look at these. First of all, why do we, and it's hard to see up on my screen, I know, but you guys can see it on your papers. Why are these questions harder? Because there's words. And when we see words, it's like, oh no. Okay, so I'm just going to talk to you guys about this. First of all, you don't have a calculator. So you're not going to get any problems like this where you'd have to evaluate using a calculator. But if it says that they give you an equation and they tell you what two numbers to plug in for x, how would you find your y? If they gave you the equation, right? This is a word problem. They gave me an equation, and then they gave me two values to plug in for x. How would you find y? You'd plug it in, right? This problem, 67, is the exact same thing as the other two we just did. It just tells you about a population, about something. But the process is not any different. Do you guys see that? Yeah. Same thing here. Right? And again, I'm not going to work these out because I'm not going to give you anything on your quiz because you guys would need a calculator for something like this. But they're telling you to find the average rate of change between where d of 0 and d of 15. That just means plug in 0 for x, find out what y is. Then plug in 0 15 for x, find out what y is, and find the average rate of change. Does everybody see that? Okay, so if you look at something like this, look at 69 and 70. Function is given. Find the average rate of change between 0 and 2. Then find the average rate of change between 15 and 50. What are they asking you to do here? Plug in. They're telling you to plug in. If you had a question and it said, in 1999 or 1990, okay, 624 CDs were sold. Okay? You guys got that? Yes. And then in 2003, 421 CDs were sold. I mean, obviously that's ridiculous that there was only that amount sold in one whole year, but just whatever. All right, and they said, what's the average rate of change between 1990 and 2003? Well, how in the world would you figure that out? Did they already give you an ordered pair? Yeah. What's the first ordered pair? 1990 and what? 624. What's the second ordered pair? 2003, good, and 421. All right, if they give you in the town of whatever, the population was boom, and the year boom. They're giving you the ordered pair, guys. You just have to pair them together. But how would you find the average rate of change? Here's my x values, here's my y. So in this case, what would your y, what would the numerator look like? What do we say? 624 minus 421, right? Over what? 1990 minus 2003. Do you need a calculator for this? No. Well, you might want to write it down and say, okay, 624 minus 421. Yeah. 4 minus 1 is 3. 2 minus 2 is 0. And 6 minus 4 is 2, right? So 203 in the numerator. What do I know my denominator is going to be? Negative. So I'm going to say 2003 minus 1990. So 3 minus 0 is 3. I got to borrow a whole bunch, right? So 10 minus 9 is 1. 9 minus 9. So 13 over 13 years. And we said it's negative. Can I simplify 203 divided by negative 13 at all? So there's your average rate of change. Don't be intimidated by word problems, please. You guys are going to see word problems, and that's okay. There's no reason to be like, oh my gosh, there's words and I can't do it. Yes, you can. Just read the information and see what it says. Questions? All right, let's look a little bit more. Ooh, transformations. We've got to know our transformations, guys. Have to know our transformations. Remember where our transformations occur. When you look at something like this, I'm not going to give you where it says f of a function. You're going to have a couple problems. I'll give you some examples. That says like, I don't know, f of x equals 1/3 times x plus 4 quantity squared minus 7. Or say g of x equals 7, absolute value of 2x plus 1 minus 3. You'll have two or three of these. And all you have to do is just draw arrows and tell me what's happening. You guys have got to know where transformations occur. So I look here and I say, okay, I have a 1/3 out in front being multiplied. What does that mean? A vertical shrink. Good. You have to put vertical or horizontal. Yeah. You have to be specific if it's vertical or horizontal. Hold on one sec. You can call it a compression if you want to, but keep moving left to right. Guys, this is a quadratic function, right? This is a quadratic function. You don't need to tell me that, but that's what this is. What is this plus 4 inside? It's going to move left or right. Which way is this one going to go? Left 4. Remember, anything inside, parentheses, underneath, inside of a square root, underneath a square root, inside absolute value, that's going to shift us left and right. What about this plus 7 down here, or sorry, minus 7 at the very end? That means I'm going down 7. Perfect. That's you showing me your work. That's all I need to see tomorrow. You do not have to write me a paragraph of what's going on. Just work left to right and tell me. Now again, let's look. This is absolute value. That's okay. Notice when I say inside and outside. What is outside the absolute values? Vertical, 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 right? What's inside? The horizontal. So this vertical out here, it's greater than 1. This is a vertical what? Stretch. Good. What is this since it's inside? Zach, this is what you just asked me. That's going to be a horizontal. Now, I would think it's a stretch because it's bigger than 1. But remember, anything with X is the opposite of what we think. So this is a horizontal shrink or compression, however you want to say it. This plus 1 that is inside is going to move me where? To the left 1. Good. And then what does this minus 3 mean? Down 3. Very good. Very good, guys. All right, how do we feel?
Good.
Yes.
So
Let's talk about one. All right, let's write this down. Let's say you have a quadratic function. What is quadratic? Okay, good. And it's shifted right 4 units. Compressed vertically.
Does that just mean a vertical shrink?
By 1/2. And shifted up 7 units. And I asked you to write that. All right, it's a function, so f of x, and it's quadratic. So what did you just say, Sam? It's squared, right? So just think about what this says, guys. Shifted right 4 units. Where is minus 4? Perfect. X minus 4. It's in the parentheses. This is a squared. I got to square it. So we got that right. Okay, now compress vertically by 1/2. Where would the 1/2 go? You guys are awesome. Right here. Good. And then shifted up 7. How would I write that? Look at you guys. Awesome. Love it. All right, let's look about this. All right. How do we figure out if something is algebraically odd, even, or neither? Plug in what?
you can do like 2 or -2.
You can do a number and its exact what? Opposite. All right, let's do A. Let's look at A together. This is how I need to see this on your quiz. You guys have f of x equals 2x, God bless you, to the 5th, right? Minus 3x squared. What is it, plus 2? Thank you. Now, we got to go through some things to remind ourselves what's going on here. First of all, how do I figure out whether I think it's odd, even, or neither? You look at the biggest exponent. The highest exponent I have is 5. What kind of a number is 5? So my 2 options are either odd or neither. That's it. When I think of the word odd, what should my answers be of each other? They should be opposites. So you're setting yourself up to say, okay, are these 2 numbers, when I evaluate, exact opposites? What is the easiest number and its opposite to use? No, we can't use 1. 2 and negative 2, positive 2. You can use negative and positive 2 every single time. If you want to use a bigger number, that's perfectly fine. Just understand you guys don't have calculators. So now take your time when you're doing this. I have 2 times negative 2 to the 5th power minus 3 times negative 2 squared plus 2. What is negative 2 to the 5th power? It's negative 32. So 2 times negative 32 is negative 64. What's a negative 2 to the 4th power? 4. Sorry. Negative 2 squared is 4. And then what's negative 3 times 4? Minus 12 plus 2. All right. So what is negative 64 minus 12? Negative 76. Good. Plus 2 gives me negative 74. Everybody with me?
Yes.
Okay, now we're going to do the same thing, but we're going to evaluate with positive 2. So I have 2 times 2 to the 5th power minus 3 times 2 squared plus 2. So here we go. 2 to the 5th power is 32, and 32 times 2 is 64. 2 squared is 4, and 4 times negative 3 is minus 12, and then I have plus 2. What is 64 minus 12? 50 what? 52, and 52 plus 2 is 54. When I look at the numbers negative 74 and positive 54, are those two exact opposites of each other? No. So your answer is neither. You need to show me all of this work. Don't get to this step and go, oh yeah, I can tell it's neither. I want to see the full, what you guys did fully, plugging in your negative and your positive of each other, but exact opposites, however you want to say it. Positive 2, negative 2. Positive 3, negative 3. Positive 8, negative 8. I need to see everything, and then you tell me if it's odd, even, or neither. What about C? Read C to me. 1 minus x squared over 1 plus x squared. Okay. Do the rules change because I have a fraction? No. What's the highest exponent you see? 2. So what are your two options? What do you think this could possibly be? Even or neither. So if I think that this function is even, what should the two answers be of each other? They should be the same. So let's get, guys, what do you want to use? 2 and negative 2? Okay, so 2 and negative 2. Notice the first time I put negative 2 first, then positive 2. It doesn't matter. Just know that when you work this out, the answers should be the same. So I'm going to plug in 1 minus 2 squared over 1 plus 2 squared. What is 2 squared? So I have 1 minus 4 over 1 plus 4, right? What does that equal? Negative 3 over 5. God bless you. So negative 3, God bless you, over 5. So same thing. I'm going to plug in 1 minus negative 2 squared over 1 plus negative 2 squared. What is negative 2 squared? And 1 minus 4 is negative 3. What is negative 2 squared? 4. And 1 plus 4 is? Okay, so I got negative 3/5. What did you just show me? Those are the same, right? So Sam just told us this function is even. Very good. Good job. All right, there's going to be one. Well, it's not totally free, but it should be. We put a picture. We put a graph. All right, let's remind ourselves. How do you figure out graphically if a function is odd, even, or neither? If it's even, what are the two things that have to happen graphically? It has to be symmetric to y. Symmetric to y, meaning y cuts it in half, right? And it has to do both things. And what? The arrows in same direction, meaning both up or both down. Sure. All right, now graphically, if I think my function is odd, what are the two things that have to happen? It's got to go through the origin and arrows in, perfect, arrows in opposite direction. Very good. So let's look at this. All right, there's no arrows here, but assume that there is. We'll just write them. Okay, so the first thing I do is I say, let me look at the ends. What's going on in the ends? Same direction or opposite direction? Opposite. Okay, so what do I think it possibly could be? It could possibly be odd because the arrows are going in opposite directions. But what does it also have to do? Go through the origin. Does this function do both of those things? So this function is odd. Good. All right, look at the next one. Look at the ends. Opposite or the same? Opposite. Okay, so I think it might be odd. Does it go through the origin? So this function is perfect. Good. All right, look at the ends. What's going on here? Same direction. So if it's the same direction, I think it might be even. Does the y-axis cut this bad boy in half? So this function is even. Good. All right, this is called the step function. Do I have arrows going in opposite or same directions? There's no arrows, right? What is this, guys? This is a big neither. Big neither.